So I'm gonna spare a few words on the project, collaborative project that we're working on. It's called PoeTree, and it's basically now a collection of poetry corpora in 10 languages. So I will say something about where the data come from, because it was not built from the scratch. So where we acquire the data, how they look like. I will say a few words on what cleaning steps we have performed to get rid of, some stuff like poems that are actually not written in a given language. About what kind of information did we add to these corpora, and finally how anyone can access the data. So this all stems from these projects. Corpus of Czech verse was built years ago in our institute. The German data comes from Metricalizer and Deutsch Lyric Corpus. Surprisingly, there are no free data available there's no free corpus of English poetry, so we had to build it from Gutenberg. And then to clean it a lot because of inconsistent annotation and tagging, so it was a couple of nice months. Spanish data comes from corpus of Golden Age sonnets and diachronic Spanish corpus. There is Corpus Mareb for French, ELTE poetry corpus for Hungarian, Biblioteca Italiana for Italian, Aoedos for Portuguese, Russian poetic corpus, and corpus of Slovenian poetry, which was actually built for the sake of poetry by Neža Kočnik. So, as you can see, the sizes of the corpora differ a lot. On the y-axis, we have the size measured in a number of poems. And so we have these large corpora of Czech and German, maybe also Russian, and quite a small corpora like Slovenian or Portuguese. But yeah, poetry is a wild thing. So giving the number of poems maybe sometimes misleading, because they tend to differ a lot in length. So, for instance, in English, you can see that it comprises way longer poems than the other corpora. Although it's not unified in periods, it's covered. So here on x-axis, it's divided into periods of 25 years. On the y-axis, you have the particle corpora, and the size of the bubble gives the portion of poems that comes from an author that was born in a given period. So, yeah, of course, you can see Italian spans to early Renaissance, while languages such as Czech, where poetry was basically invented in the late 18th century, only cover this part. However, the core where all the languages are not badly represented is the second half of the 18th and the 19th century. Then, of course, in the 20th century, we face issues with copyright, and it's really hard to proceed on. So, as for the cleaning steps we've performed, so first was to try to detect texts in foreign languages. For this sake, we have used LangDetect, which is a Python library, and basically we manually checked everything that has a probability of being in a given language lower than 0.99. This is a super high threshold, but even so, we were checking just a few dozens or maybe hundreds of poems. So it was it was perfectly able to go through manually, and this didn't detect like a huge number of texts. For instance, in English corpus, this was just 19 poems, almost half of it written actually in Latin. The only corpus where we faced a larger number was Italian, where Latin comprised some 200 texts, and of course it's Italian, so it's actually in the early stages it's really hard to tell these languages apart. Then we came to the duplication, because there were duplicate poems coming from different editions present in the corpora, so we wanted to get rid of them. Not actually to get rid of them, but to mark them as duplicate, just to keep them in the corpus, but to mark them as a duplicate of another text. This is not that difficult task. We can just build some sort of a similarity matrix of poems, comparing each poem of each author to each another poem of this given author, measure the similarity, and if it exceeds a certain threshold, we just call it being a duplicate. At first glance, we can use simple edit distance. Take one text, compare it to another, and to count the number of editing steps needed to get from the first one to the second one. By editing steps, I mean insertion of character, deletion of character, or replacement of a character. However, this would not capture cases like this, which are quite common in poetry. And it's a simple case where we have a long poem, and in other edition, this long poem is divided into parts which are considered standalone poems. This wouldn't be captured by edit distance, because in order to get from here to here, you would need to remove a vast majority of its characters, technically speaking. Therefore, we use something that is called approximate substring matching, but basically it means that with these two texts, you first find the best possible alignment of the shorter one, and then measure the edit distance between the corresponding parts. The duplication itself, we have approached it via graph representation. So each node is a poem, and we draw an edge between them if it exceeds certain threshold of similarity. So this is actually how this poem we've seen before would be represented. The long one with its parts being connected to it by the edge. And this is these are the histograms, the distribution of similarities in particular corpora. In each corpus, it peaks somewhere between 0.4, 0.5. It differs language to language. Would be interesting to check how this particular number or how this particular peak may depend on a language type or typology. But if we look closer to it and switch the y-axis to a logarithmic one, we can actually see that the distribution is bimodal. We have this main peak where the similarity is pretty low, meaning these poems are not similar to each other, not duplicate of each other at all. And then we have this peak at number 1, which says, yeah, there are no editing steps needed. These texts are the same. And the question, of course, is where to cut it, where to say, oh, this is already a duplicity, or this is maybe a related text, but not a duplicity at all. And yeah, the question is not really straightforward. It would depend on for what sake would you use the deduplication. Hence, we use the rule of thumb and cut it at 0.75. But in the data itself, we keep the original measurement, so it's easy to perform your own deduplication with other setting of threshold that would fit your needs. And by measuring the similarities, the quest is not done, because we would like to mark a poem. In order to mark a poem as a duplicate of another, we need to decide which is the primary variant and which is a duplicate. In case of these simple components, it's easy. We just apply some rule like, okay, if they are of the same length and one is older than the other, we consider the older to be primary. But we may have a more complex components like this one, where are 3 versions basically of the same text in a German corpus. One is shorter than the other, one has just 16 lines, the other one has 14 lines, so we can apply another rule. Then we come to cases where we either need to solve it manually or just to decide by a random. This is how the corpora shrinked after the deduplication and the removal of text in foreign language. It's not massive, but still in Czech corpus, in German corpus, the duplicates comprise about 1/10 of all the texts present there. Now we get to what kind of new information we have provided to this data. So first of all, it was universal dependencies. Tokenization, lemmatization, POS tagging, and syntactic annotation was performed by means of UDPipe for all the corpora. We do not have the evaluation for all the languages yet of how accurate this is. The only one where we have it is Czech. And generally speaking, tokenization is absolutely okay. Lemmatization is a bit worse than in contemporary non-versified text for which UDPipe, or where UDPipe was trained at. The same holds for POS tagging. Syntactic annotation is not a great. I think the accuracy was somewhere about 65%. So the goal is to train a new model specifically designed for PoeTree, and its peculiarities, syntactic peculiarities, in order to boost the syntactic annotation here a bit. Another step that we performed was that we took all the authors in all the corpora and linked them to their BIAF and or Wikidata identifiers. This way we were able to link the pen names to a single entity, and also to get more metadata on the authors, such as the date of their birth, country of origin, and so on. The most challenging task that we were facing was named entity recognition. because we were aiming at least to detect and to link the locations that are mentioned in at this part of this corpora. We've tested the named entity recognition with Flare, NameTag, and Spacey, out of which only Spacey has models available for all these languages. Beside that, we tried a few short learnings with different GPT models. You know, just asking to find a named entity, asking GPT to find the named entities in a given text, and providing it with some examples and the structure of the output that we wanted back. For each language, we made a random sample of 100 poems that was manually annotated in order so that we can check the accuracy of the output of these methods. This is how it looks like. The darker blue columns give a precision of the recognition, while the darker orange columns give recall of the recognition. The lighter parts above them, like these, give the precision and recall when we don't look for exact match, when we're just looking for an overlap. When the gold standard and the output of the tagger overlap, this might be the case of someone includes, or the annotator includes the into the named entity, while the tagger would skip it. So it's not a big deal actually. And these boxes show where available the reported F-score for these taggers on non-PoeTree texts. Generally, what we can see here is anywhere we look, accuracy in PoeTree is lower, sometimes very, very significantly lower than in non-PoeTree. BERT models, they were available, which is NameTag for Czech and Spacey for English and Slovenian, tend to outperform all GPT models. However, the same tools without BERT models, like for instance Spacey for French or for Hungarian, is not performing nearly that good. GPT-4 and GPT-4 Turbo, as expected, outperforms GPT 3.5. And GPT-4 tends to have a slightly better recall than GPT-4 Turbo, while it has a significantly lower precision than Turbo. And given that by time when we were dealing with this, GPT-4 Turbo was like 3 times cheaper than GPT-4, we decided to go with that to annotate the entire corpus. So Czech was annotated with NameTag, English and Slovenian with Spacey, and the rest with GPT-4 Turbo. This was not the end of the quest, because we aimed to not only recognize the entity, but to have them linked to a common knowledge base. As in this example, to have the information that Cařihrad in Czech, Constantinople in German, and Constantinople in English, they all denote the same entity nowadays called Istanbul in Turkey. Ideally, to have its Wikidata ID in order to get more metadata on these entities, such as its coordinates, for example. Yeah, a similar case is the Plymouth can refer to a city in UK, but also to a completely different place in Massachusetts. And as you probably know, for named entity linking, there's quite a number of models available. We've tried a bunch of them, and the result was terrible. It was worse than where one would get just by sheer guessing or assigning a random entity. And this is not because these tools and models are bad, this is because PoeTree is weird. My favorite example is River Nile in English corpus, which is quite a common thing that poets tend to refer to, but instead almost always it was disambiguated as American death metal band Nile. And there might be a reason for that. Personification, the Nile forth rushing on his glorious race, and the Nile spills his overflow, or the music of the lordly Nile. These are all contexts that usually refer more to human beings than a river or any other location. And because we desperately wanted to have these linked to a knowledge base, we decided that we will go manually for that. So we have assigned each named entity there in these corpora the first thing that Wikidata API would return for this, and we are disambiguating this manually, which is super demanding task since, for instance, in English corpus, which I'm trying to disambiguate, there are, I think, 12,000 locations found. So English is not nearly done, but we have this disambiguated already for Czech and for Slovenian. When it comes to accessing the data, they are all available in a unified JSON structure that looks like this. And if you are interested in particular details, you may find this description on our website. All the JSONs may be downloaded from the Zenodo, and also can be accessed via REST API from our website. And there is a Python package and an R package that you can use to get the data, or basically to access the API more conveniently for those who want to just browse the text or look for some examples. You can use a full text search across corpora, like this, in Warsaw, in Poland, half the world away. And finally, while we will include soon the named entities into the JSONs themselves, they are now for the two languages where... Interesting. Interesting. I'm afraid it's trying to get quite a lot of data into this mobile connection. So I'll try to access it here. Oh yeah. So there is this neat map which shows all the locations found in Czech corpus. As you can see, there's quite a lot of Polish entities in there. We have used the color coding to for things like the names of the seas, countries, continents, rivers, and mountain ranges, and it's especially because these entities tend to be really large, and when you want to place a coordinates of them, it's more or less random, like where you, I don't know, where Europe might be here. It's likely, yeah, continent, somewhere in the middle of Germany, or River Elbe, which goes all this way, is likely located somewhere nearby Dresden. Maybe, yeah, River Elbe. So in order to, so that one can filter these large entities out, you have to do it this way. Yeah, you can use this to access the particle text like this. It has some other features like you may limit it to authors born in a certain time span, and to check how the entities referred in poetry change over time. You can even filter it by particular author's name, and yeah, you can play around with that. Eventually, you can take it with you to your summer holiday and read the poems about this and that particular place. At the very end, just a disclaimer: the JSON structure, all this, we don't aim to build any kind of standard. We don't aim to build a replacement for TEI, because it doesn't simply make sense. It's just a thing that serves our needs here best, but is not meant to be definitely a general standard. Thank you very much for your attention.